Hello, everyone. Welcome to tonight's edition of the Australian FRC workshop series. We're really pleased to have Mel from Team 3132 here tonight. Mel has been on the team since, I think she was in about year 10. Basically, the first year the 3132 existed. And now she's a college graduate. She's a graduate school graduate. She's a teacher in a local high school. And she still mentors the team. So she also was the Volunteer of the Year 2 years ago at one of our Australian regionals. So she does a lot. She's here and she's going to talk about an introduction to CAD. She's going to build some parts with you all. So I will turn it over to Mel.
All right, thanks, Luann. Yes, my name's Mel. I've been with Team 3132 for going on 12 years now. What I'm going to talk to you guys about tonight is about using CAD in FRC. It's just going to be an introduction to using CAD, to doing sketches, making parts, talk a little bit about all of the different options that you have, specifically in the context of Fusion 360. So I hope you have all already gone ahead and downloaded Fusion 360 onto your computer. If you've got that set up, then you'll be able to follow along with me as I make some of these parts here tonight. So firstly, what is it that we use CAD for in FRC teams? I think when we look at that, there's really two options here. There are some teams that are just using it to make individual parts, maybe for the 3D printer. And some of the parts we make tonight might look a little bit like something that you might design to come off a 3D printer, whether that's a spacer or a camera mount or something like that. And then on the opposite end of the scale, you've got those teams that model their entire robot in Fusion 360 from the ground up, all the fasteners, bearings, maybe even the electronics. So two different ends of the scale there, whether that's making individual parts or modeling your entire robot. When it comes to Fusion 360, which is what I'm using tonight, Fusion 360 is one of about 4 different options that you've got when it comes to using CAD in FRC. Some of the other alternatives, as you might know, would be Autodesk Inventor. We've also got SolidWorks and we've got PTC Creo. The reason that I've chosen to use Fusion tonight, a couple of different reasons. It's really, really easy to download the free software directly off the website. So that makes it easy to access for everyone. And the other thing is it's also, it will work on Macs. So I find that really useful with my students because they can be using Fusion on their computers at home, particularly at the moment when you can't necessarily meet in person. Whereas if you were using something else, you'd be reliant on the computers in your workspace for that. So Fusion is really good from the point of view of it being accessible to everyone. It does have a few downsides though, mostly revolving around how different parts are assembled together to make big assemblies. So if you want to have your entire robot in CAD, Fusion probably isn't the platform for you. If you're just trying to make parts for 3D printing, then it can be a really great choice. So I'm going to screen share now and show you guys a little bit about what we have in Fusion 360 and what the options are. Okay, so if you're unfamiliar with Fusion 360, when you open it up, this is basically what you're going to be seeing. You might also have open the data panel over here on the left-hand side. And the data panel is basically just where all of your folders are sitting. So you can create new folders here. Don't do what I've done, which is just have parts sitting around everywhere. Try and set up a nice file structure. And as I go through all of my parts tonight, I'm going to have them all sitting in this folder over here. So what can we see on the screen here? Well, this is what you're going to be faced with when you start out. So if we look at the screen, we've got a few different zones. So the main zone down here, this is the workspace. When you make your part, that's where it's going to appear. We've got some options up the top. We can save, we can make new parts and things like that. But the really interesting stuff is all over along here. So you can see at the moment I'm in the solids tab and I'm actually going to stay there throughout the night. There's other features here in surface, sheet metal and tools, but these are really advanced features and not something that I find particularly useful in FRC. So sticking here in the solids tab, we can see we've got a whole bunch of different options running along here. Now, if we go through this section by section, first of all, we've got create. So all of the options in the create menu, and we can open up the drop down and you can see there's way more down here. This is all to do with creating a part, a three-dimensional part, whether that's by extruding out a rectangle or revolving something like a cylinder. This is where all of the tools are that allow you to do that. The most important one is this one here on the left-hand side. And that allows you to create the sketch that your whole part is going to be based on. And we're going to spend some time looking at the options that appear when you open that Create Sketch button. We also have a Modify menu. Okay, after you've created your part, it's three-dimensional, and you want to do something else to it. Maybe you want to fillet or chamfer the edges off. You want to hollow out the inside or something like that. We've got some options down here as well. And if we get time tonight, we might have a look at that shell function because it's kind of cool. We've got assemble over here. So if you are trying to make an assembly, so in Fusion 360, you can assemble things. It gets a little bit unhappy if you try and put a lot of parts in. You know, we're talking like 10 or more, it's not super happy. So like I said, not super great for an entire FRC drivetrain. But if you want to put a couple things together, like test if your camera actually fits in that camera mount, this is where all the tools are that allow you to put those things together in a particular way. And then we've got a couple more things. Construct. They allow us to create things like offset planes or extra axes or extra points. And we can also use the Inspect tool, which is just measuring things you've already made. Over here, we have this tree that we can open up. The one that's really useful to us is the Origin menu. That allows you to see where your X, Y, Z axes are, where all of the planes are, and where your origin is. We also have over here, here's the cube. So the cube is what lets you rotate a part around. So you can click on the corner and you can see the cube's going to spin, and that'll let you view your part from different angles. Now, if you're not doing this with a mouse, I would highly advise you to go and grab one. CAD is much, much easier if you're using a mouse, particularly one that has a scroll wheel. If you're doing it just on the touchpad, you're going to struggle a little bit. So a mouse is really helpful. Okay, so we've got that up there. And then as we work through our parts, we're actually going to see some stuff appear down here at the bottom, which I might touch on after we got a few sketches and extrusions going. So with that, we might get started on a part. So what I'm going to do is I'm going to open up a part drawing. I'll give you about 30 seconds for you to take a screenshot of that or a photo of that. And then I'm going to return to my main screen here. Okay, so here's the part drawing we're going to start with. I think I've got 7 or so lined up for tonight, and we'll see how we get on. So here's the first one. If you want to grab a screenshot or take a photo of that, that's the part drawing that I'm going to be starting out with. So as you can see, it's just a sketch. We might go ahead and extrude that out to a thickness, but in this particular part, we're just going to be focusing on some of the different features that you get when you open a new sketch. Okay, so hopefully that was enough time for you to grab an image of that. If at any point you do have a question or you want me to go back over something, just pop a message up on the YouTube video. And I think Luann will let me know of any questions that come up over there. Okay, so let's get started. Number 1, we're going to save this. So I'm just going to give this a name. I'm just going to call it part 1 because this doesn't really have a name. Okay, now this is just a sketch. It's just a 2D shape. So to begin with, I'm going to go here up to Create Sketch. I'm going to click on that. And as soon as I do that, you should see you get 3 different options for which plane you want to place the sketch on. Now, since this is just a 2-dimensional sketch, it doesn't really matter at all which one you pick. I'm going to pick XY because it's like the Cartesian plane and it's just a bit easier to think about. So I clicked on the XY plane. You would have seen as I hovered over them, they were highlighting over here. And now I've got a sketch open. So you can see that we've got, like a Cartesian plane, an X-axis and a Y-axis. And some indication as to the size and the scale that we're looking at. So we've got a 25mm mark up there. Now you'll notice when I open that sketch up, basically everything has changed. All of these options up here are totally different, and a new tab is opened, which is called the Sketch tab. So let's have a look at the things that we have here first of all. So the first section in the Sketch tab is the Create menu. Now this is the menu that gives you all of the options for the types of lines that you might want to draw. We can just do a basic straight line, and you can see that's actually got a shortcut L. But we've also got features for making different kinds of rectangles, different kinds of circles, arcs. You can do polygons with as many sides as you want, ovals, all different kinds of slots, and so on down the list. We also have some useful ones down here, which are the mirror tool, the circular pattern, and the rectangular pattern, and then something that I'll talk about in just a moment, which is project. Right at the bottom, we also have the dimension, which is what allows us to apply sizes to everything. So that's in the create menu. In the modify menu, once you've set up a sketch, you can go in and you can adjust your lines using some of these tools. So we've got a fillet tool, which will round off the corners. We can trim things. We can create something that's offset a little bit. And then we have the constraints. So this is for when maybe you've got a part of an arc and a straight line, and you want them to be tangent, or you want the center of a circle to be coincident or lie on a line that you've drawn somewhere else. You want two things to be parallel or perpendicular. We've got a whole bunch of different options here in the constraints menu. So this is what we're going to be using. So the first thing when it comes to creating a sketch in any CAD program is to figure out which part of the sketch you want to lie on the origin. And that's actually a really important decision in parts that have some kind of symmetry, a little bit less important if, like in the part that we're doing now, there really isn't any symmetry at all. So if I just go back over momentarily, I think what's going to make sense for me tonight is if I place the origin of my plane down here in this bottom left corner, and I'm going to place everything in this sketch up in the first quadrant. Okay, now before I start doing anything else, I'm going to go and I'm going to use the project tool. So that's here in the create menu. I'm going to go select project, or you can also just hit P on the keyboard to bring it up. What the project tool lets me do is it lets me take geometry that exists outside the sketch and bring it into the sketch. So that can be either, you know, a line or an edge on a three-dimensional shape that's in this file, or since I don't have anything like that, what I'm using it for is I'm going to actually project the x-axis and the y-axis into the drawing so that I can dimension to that and I can constrain things to that. So I'm going to go and project my x and y axis. And what that allows me to do in the long term is make sure that everything's really well locked to the origin. Okay, so looking at my shape, I can see that I've got a couple different features. I'll pop it up again. I've got a lot of straight lines with different angles and things like that going on, as you can see over on this side. I've got a full circle. I've got this little fillet here on the corner, got a half circle, and I've also got a hexagon hole up here. So where to start? Well, I'm first of all going to go and select the line tool. So for this part, I think I'm going to start by drawing as many straight lines as I possibly can. And then I'm going to come back and see about adding features that aren't straight lines. So I'm going to start down here in the origin. Now I'm going to zoom in first and get, you know, a sense of scale. So there's 25 mil. The overall width of my part is 14. So I need to be pretty zoomed in. I think that's probably about okay. It's always a good idea to be working at about the right scale so that when you add your dimensions, everything doesn't just go horribly, horribly wonky, which is what will happen if you're too zoomed out or too zoomed in. Okay, so I'm actually going to ignore that little fillet in the bottom left-hand corner, and I'm going to pretend it's just a right-angled corner. I'm going to add that fillet in later. So I'm going to start at the origin, bottom left corner. I'm going to come over a little bit. Here's my bottom. Okay, it's going to come up a bit, go over. We're going to come up a touch, bit of an angle, bit of a straight line like that. And at that point, I'm going to stop drawing straight lines because I know that's where my half circle is going to go. What I will do is I'll take one more straight line. So you can select it up here, or you can press L. And I'm just going to go up to that point there. Okay, so those are all of the straight lines in my shape. Now, I'm going to put all the features in, all of the shapes in, and then I'm going to dimension it at the end. So the next thing I'm going to pop in is I want to put in that half circle up here. So I'm going to open up my create menu, and I'm going to look for a half circle or an arc. Now you can see we've got a bunch of different options. We've got 3-point, center point, and tangent. The one I'm going to use here is the center point. The way the center point works is your first click is the center of the arc, your second click is one end, and your third click is the other end. So center, one end, other end. That's not quite the same as the other arc tools. So for instance, the 3-point arc, 1, 2, 3, and you will have seen there that the first click was one end, the second click was the other, and the third click defined the radius. So that one works a little bit differently. Just get rid of that now. Okay, so there's my half circle. I'm going to put my full circle in as well. That's living down here. Okay, and then I'm going to pop my hexagon in. So first of all, just clarify the circle is up there. You've got a few different options, but I hardly ever use anything that isn't the center diameter circle. So you can pick it from the create menu, or you can just press C for circle. Okay, and then the last thing that we need to put in here is that hexagon shaped hole. So that's a polygon. Then I open up that polygon menu. Now we've got a couple different options here. We'll just grab that Inscribe Polygon and have a look at what that does. So first click should be the center, okay, and then second click is going to define the size. So that was the inscribed polygon from the polygon menu. The default setting is always a 6-sided shape, and I've hardly ever had cause to do anything that wasn't a 6-sided shape. So center, first click, and then second click defines the size. So there's all of the different features of my sketch. Okay, time to add some dimensions. So first of all, I think I will give this some overall sizes. So you can open up the create menu and select sketch dimension, or it's a lot easier if you just hit D for dimension. Now, I know that I need to come back in and fillet this corner. So I'm going to be really careful about where I place this dimension. I'm going to be careful to place it, let's see, from the corner here to the origin. Sorry, my mouse just decided it didn't like doing that. Okay, so from one end of the line to the other, now that thing's at 16 millimeters, I'm going to change that to 14. Okay, the next one from the origin up to the top of that line there, that's 10 millimeters. Okay, so I've added that dimension and you can see that immediately something's gone wrong. So what's happened here is that although I've created this arc here, I never actually told it that it was supposed to be tangent to the straight line. So that's immediately a problem. So, and that's where the constraints come in. So if I go up into my constraints menu, let's see if we can find something to fix that. Okay, having a look through here, I've got a tangent option. So let's go ahead and make that arc tangent to that line. Much better. Okay, what else can we get in here? So D for dimension, I'm going to dimension the size of this line here. Now that's conveniently already 3 millimeters, so I'll just confirm that. This little one here, also 3 millimeters. So I'm just typing in the numbers and then hitting enter. Okay, and then the height of that line is 4. There we go. Okay, and we can see that as soon as I put that in, we immediately had another problem. Now that line is going inside the arc. So I could try and add a constraint, but I'm actually just going to drag it around a little bit until it looks like what it should do. So you can actually, so long as a line is blue and not black, black means it's locked in place. If it's blue, you can grab bits of it and move it around. So I'm going to grab that corner in there and drag it out like that until it looks more like what I really want it to look like. Okay, other dimensions I've got, I can see this is supposed to be 2.4. Okay, I'll pop that in. And then I'm going to have a bit of a think. Okay, I'm going to dimension my arc up here. Now on the drawing, that's got a diameter of 4, which is a funny way to dimension an arc. So clearly that's meant to be a radius of 2. Now, nice thing about Fusion and other CAD programs is you can actually type in a little bit of math and it will do it for you. So I know I'm looking for a radius for a circle of diameter 4. So if I type in 4/2, that's actually going to calculate that that's 2. Now, obviously, that's not super useful if you're just dividing something by 2, but you can do a decent number of calculations just in the dimension box. Okay, so there's that one there. Now, what's going on here that means that this isn't fully black? So you'll see I've got black lines and blue lines. Black lines are fully dimensioned, fully locked in place relative to the origin, but anything that's blue is either lacking a dimension or a position. So I can see actually, if I zoom in up here, something that's gone wrong, okay? That line there is supposed to line up with that point over here, and it clearly isn't. So I'm going to use now a different tool, which is called the construction tool, which is over here. I should do that when I don't have a line selected though. Okay, so I'm going to click the construction tool, and then I'm going to click the line tool. Now I'll show you what this does. I'm going to draw a line from that point over there to that point over there. And that creates a dotted line or a construction line. So I can use those lines to constrain things together or to add extra dimensions. But when I exit the sketch, they're not going to form part of the profile of the shape when I go to extrude it. So what I want is for that line to actually be horizontal. So I can go up to my constraints menu and click on that horizontal vertical tool. I click on that and I click on the line. You can see that's actually forced that line to become horizontal, and it's lined those 2 points up. What else have we got going on here? We've got this hexagon. Okay. So what's happening to the hexagon? Okay, well, you can see that I can spin it around like this, which isn't what I want. So what I'm going to do with that hexagon is I want the points of the hexagon to lie on that construction line. And that's actually also quite easy to do. I can use a coincident constraint that will take a point, like a corner, and force it to lie on the line. There we go. That's now the right orientation. And I should just need to give it a dimension, point to point of 2 millimeters. Lovely. So that whole top area has turned black, so that's all fully dimensioned. We can now take a look down here in the bottom corner. Let's see, first of all, I'm just going to make this hole the correct size. So radius of 1.6, so that's going to be 1.6 times 2 for the diameter. There we go. Okay, now I haven't positioned it yet, but we're going to come back to that. What I'm going to do next is I'm actually going to add that fillet in. So I didn't do that in the original sketch because I got this tool up here, the Fillet Tool. I take that tool and I click on the 2 lines that I want to put a corner between, and I type in the size of the fillet. So we can see in the drawing that's a radius of 3. There we go. We have a radius of 3 put in there for us. Okay. Now, to position that circle, from the drawing, I can see that the center of that circle is also supposed to lie at the center of that radius. So I should be able to just grab that coincident tool and click those 2 centers together. So the coincident tool will also lock the same 2 points together. As soon as I've done that, I can then zoom out and have a bit of a look. Everything on here has turned black, so it's fully dimensioned, and it also knows where it is relative to the origin. So that sketch is now totally done, and I can actually go and exit the sketch. So up here, click Finish Sketch. Okay, we're back in our original mode, and at this point, I can take a 2-dimensional object and make it 3D. The way that I do that, and I'll just do this as an example, I'm going to go up here and grab the Extrude tool, click on the shape, and you'll see that it's excluded those 2 holes, and I'll choose a thickness to extrude that to. So maybe I want to extrude that to 5 millimeters. Whoa, that's massive. Let's go slightly smaller. 2 millimeters looks a bit better. There we go. Now it's a 3-dimensional object, and you can see now that it's 3-dimensional that the cube up here becomes more useful. I can use that to rotate around the object. Or if you're using a mouse, you can actually just hold down the Shift key and the scroll wheel and drag the shape around like that. So if you've got a mouse, that's much easier to do. Okay, so there's our first shape. So we've looked at using some of the straight lines, arcs, circles, polygons, and other features that we've got in the Create Sketch option. Okay, so there's the first part. I'll just hit save on that. And we'll take a look at the next thing. So again, I'll just bring this up on the screen for a moment so you can take a screenshot if you'd like. So this is another sketch that we'll do. This one has a lot of sort of curves and radiuses going on. So it's a bit of a different shape here. the interesting thing about this one is that this one it really does matter where you put the origin in this part. This has got a very natural center to it, right bang in the middle of the part. So when we do the sketch, we're going to make sure the origin is right on that mark there. We're going to work around the origin. You can see we've got a lot of radiuses here, some dimension markings. Another good thing that CAD training is for when it comes to students is that if you make enough of these parts, you get really good at reading engineering drawings. So this can be a great thing to do for your manufacturing students in some downtime. Have them go and make a bunch of parts in CAD, and they really start to get the hang of reading engineering drawings, which is nice. Okay, so hopefully that's been up for long enough. Let's flick back over. I'm gonna make a new part. I'm gonna call this one part 2. Okay, so I'm just going to start as I did before. I'm going to grab create sketch out of here, and I'm going to place it on the XY plane. So you can see that's being highlighted over here on the tree when I do that, XY plane. And again, I'm going to zoom in a touch. So I'm at the right sort of scale here. Okay, so for this part, I might actually just start by whacking that big circle in the center. But only after I've gone and projected my X and Y axes. So no matter what I'm doing, I always start by projecting the X and Y axes because you can never know when you're going to want to constrain something to them. So down here, project, or just press P. I'm going to project the X and the Y axis and hit OK. So there we go. That's the purple lines. Okay, first thing I'm going to do is I'm going to grab my circle tool from up here, and I'm going to do the big circle in the center. And I might actually just add a dimension early on just to give myself a better sense of scale. That's got a diameter of 8.4 millimeters. Okay. Now I kind of know what scale I'm working at. Okay, so what do we have going on here? Okay, well, this shape is actually a really good candidate for a lot of construction lines. So the first thing I'm going to do is I'm going to grab that circle again, and I'm going to set it to construction mode. And then I'm just going to draw a circle centered at the origin again, like this. And I'm going to add to that a dimension of 8, radius 8 times 2, which will make a diameter of 16. Now what that is in my drawing, that's actually this curve up here and that curve down there. Okay, so that's gone in there. Now I'm going to add in 2 more circles that are going to be the holes on the left and the right. So undo or take off construction mode, grab that center circle tool, and I'm going to do 1 circle over here and 1 circle over here. Now I'm also going to put some dimensions on these guys. So I'm going to dimension the left-hand one and make that 2 millimeters. Okay, the right-hand one, I'm going to put a dimension on that, but instead of typing in 2 millimeters again, because they're the same size, and because I suspect that even if I was to change something about this part, I would still want them to be the same size. Instead of typing in 2 again, I'm going to make sure that the number is highlighted, and I'm going to go and click on that other 2 mil over here. Now you can see that's entered D3. So what that's going to do is it's going to take dimension D3, which is the one I'm hovering on over here, and it's going to make that circle the size of D3, regardless of what size D3 actually is. And you can see now it's made that 2 millimeters. Now why this is useful is because if I change my mind later on and I decide I actually don't want them to be 2 mil, I want them to be 3 mil, I can change that one number and both holes change size. So that's really useful in FRC when you're doing something that has a lot of bolt holes in it. For instance, if you change your mind halfway through and decide that actually you want them to be M5 instead of M6, you set it up like that, you just have to change a single number. So I'll just change that back to 2 mil. There we go. Okay, now I'm also going to just position those relative to the origin. So more than one way that you can do this, but I'm simply going to put a dimension from the center of the circle to the origin. And I'm going to make that half of 32. Okay, and then I'm going to do another dimension to the other hole. And again, I'm going to click on that dimension. So now they're the same distance. Okay, Now you'll see that this hole over here is still blue, so that means something isn't quite stuck where it should be. So let's grab it by its center and drag it. Okay, I can see what's gone wrong. It's not lying on my x-axis. So I need to make it coincident with the x-axis. So I'm going to grab that coincident tool out of the constraints menu, and I'm going to make the center of the circle coincident with the x-axis. When I do that, you can see it's gone and turned black, which is great. Okay, so we've got those two holes in there. Now, I think I'm going to go in with a little bit more construction geometry. So what I'm going to do now, just flick over to the drawing, I'm going to put in a couple of construction circles that are the outer arcs that we've got around these circles here. So I've got a radius of 2 for a diameter of 4 for those. So grab a circle, set it to construction mode, and I'm just going to put a construction circle over there, and I'm going to set that dimension to be 2 times 2, which is 4. Okay, now I might just show you another tool that we've got here. I could go over to the other side and create the same circle and link those two dimensions together. What I'm going to do instead, just for the sake of showing you how it works, is I'm actually going to go and grab that mirror tool here. So the mirror tool allows me to choose an object. So I'm going to choose that construction circle and mirror it over any line. So I've selected my construction circle. Now I'm going to go and select my mirror line, which is going to be the y-axis that I projected into the drawing. And you can see when I hit OK, I now have the same circle over on that side. Okay, so now what I want to do is just do the outline of the shape. So I'm going to grab some lines, some straight lines, and I'm going to try and basically join up the outline of the shape using some straight lines. So I'm just going to put them in, and then I'm going to come back in a bit and figure out exactly how they attach to the circle. So I'm just attaching 4 straight lines going between all of these circles. Just like that. Okay. Now, very clear from the drawing that these lines are supposed to be tangent to the circle. So let's grab that tangent tool and start tangenting them up. So I need to go around all 4 of the lines on both ends and make them tangent on both ends to the circle they're in contact with. Okay, I'd already done that one. Okay, so they're all tangent now. And now I'm just going to go in, and you can see, although I've got the shape, the outline there, it's in construction mode. So I'm just going to go and grab some center arcs, center point arcs, make sure they're not in construction mode, and just finish the outline of the shape. With some center arcs like that. And then the same deal on this big circle there, and also down the bottom. Okay, now you can see that as soon as I did that last one, that shape turned blue. So that means it's now a closed shape. Okay, so that's the outline with some holes in it. I just need to do now these funny little slot things that I've got on the left and the right. So I'll do one of them, and then I'm going to mirror it again over the y-axis so I don't have to go and do it on the other side. So again, this is a candidate for some construction. I can see that I've got a radius of 11 and a radius of 10, and those appear to be centered around the origin again. So I'm just going to do those 2 circles, make them any size, and I'll just whack some dimensions on in a sec. So 2 circles. The inner one has a radius of 10, so 10 times 2 in the dimension box, and the outer one has a radius of 11, so 11 times 2 in the dimension box. So I've got my construction circles now. Okay. And then I'm just going to grab some straight lines, and I'm going to do some horizontal. Oop, that's set to construction mode. Right. If you enter a line and it's in construction mode and you actually wanted it to be a normal line, just click on the line, click on construction, and it will turn it back into a normal line. So I just made that mistake. Actually, I'm going to deselect construction now, and I'm going to do my second line down here. Now, you'll see when I did those, I made an effort to draw them horizontal, and that's meant that this horizontal symbol has popped up here. If that didn't happen, you could go and make them horizontal using horizontal vertical up in the constraints menu. Okay, so those two lines, they're supposed to be separated by 6 millimeters. So let's bung a dimension in here. Okay, now they're clearly meant to be lined up. So I'm just going to actually join them up with a construction line like this. Okay, and I'm going to force that line to be vertical. So that's lined them up. Okay, and this part is also symmetrical top and bottom. So I'm going to stick a dimension that goes from that line down to my origin. I'm going to make that. Oh, actually don't need to make that. It looks like I centered it anyway. Okay. So we'll just get rid of that line. Didn't need that one. I'll leave that line in. Apparently that was necessary. Okay. So now we've got those two shapes set up. And I'm just going to go and fill in the rest of the shape using some arcs, center point arcs again. So center point here to here, center point from here to here. I just realized I've had both of those in construction mode. Let's just do that again off of construction mode. Center point arc, fill in this shape. That's better. Nice dark line and nice dark line there. Okay, now to get that repeated over on the other side, I'm just going to mirror that. So I'm going to grab the mirror tool. I'm going to select 1, 2, 3. Just trying to grab that last line. Come on. I'm a little bit uncooperative. I think I've got it over the mirror line there. Didn't quite get that last line. You can see 3 of them have mirrored. The last one hasn't quite managed to mirror. Okay, I'm not going to win that fight with trying to hover over that line, so I'm just going to tack that last one in using an arc. Okay, so now I've got all of the components of that shape there. And that should be everything for the sketch. I can now finish the sketch, and now I can extrude this shape. So if I grab the extrude tool, okay, select the 2 areas that I want to extrude. The reason it's divided into 2 is because it's seeing that projected X and Y axis and thinking that's part of the outline, but just make sure you select the 2 regions, give it some kind of thickness. I'll go for 2 mil again, and you can see we've made a 3-dimensional shape here. Okay, so that's part number 2, using some tangent constraints there. Okay. So there's a couple of different things that you can do just in 2 dimensions. What we're going to do now is we're going to have a look at some of the features that you get once you move into doing some more sort of 3-dimensional geometry, which is really what we want, particularly if you're looking at this for 3D printing. So first 3-dimensional part we'll make is going to be this one here, some kind of mounting bracket. I'll leave that up for a sec so you can take a screenshot. So you can see here we've got a isometric drawing up in the top right, and then just an orthogonally projected couple of different views on the left-hand side. I've got a front view here, a side view, and what looks like a top view up there. So for this part, it's not super duper complicated. You could probably start making it from any point of view, and you'd get there in the end. But for more complicated parts, it's a good idea to think carefully about where you're going to begin, just to save yourself trouble later down the line. So I think for this part, the best thing to do is going to be starting down in this point of view, so down here on this side view here, by drawing this L shape and then projecting that out to be the correct length. And then once I've got that L shape set up, I'm going to come back and add some of the different cutouts and holes and other features that I can see in the other 2 views. So that's what I'm going to do. I'm going to start by doing that L shape. So if I pop over into Fusion, I'm going to open up a new part and call this part 3. And I'm going to start with a sketch, plonk it down on my XY plane, and I'm going to start by sketching that L shape, which is a super easy shape. So easy, in fact, I don't really need to project my X and Y axis. You could if you feel that you need to, but I'm actually going to be able to get away without it because everything here is horizontal and vertical. So it's basically just making an L shape with straight lines using the straight line tool. Okay, Now you can see that I've goofed that top a little bit. It's not actually horizontal when it should be, so I'll just drag it down a touch and then go in with my horizontal vertical constraint, make that horizontal. Okay. Now I've made sure that I started my lines at the origin, so 2 of my lines are already black. They know where they are, they just don't know how long they are. And I can just go in now and start adding some dimensions. So down here we've got 60 millimeters. I've got 30 over here. I've got a height of 80 mil. And I've got a thickness up here of 25. Okay, so everything has now turned black and I've just got my L shape there in the sketch. So in a moment, I will finish the sketch and I will extrude that. And this time I'm going to show you at least one of the other features that we get when we do extrusions. So finish the sketch. Now I'm just going to turn this slightly using my mouse, the scroll wheel on my mouse. So I've rotated the sketch a touch just so I can see what's going on when I extrude. I'm going to grab my extrude tool. And now if we look at the sketch one more time, you can see that it's actually symmetric across this sort of middle line here. So when I extrude it, I really want to keep my origin in the middle of the part. And there's a way that we can do that by changing the settings on the extrude tool. If I use the extrude tool just as is, it's going to send all of the extrusion out in one direction, and then my origin will be stuck on one side. But that's not what I want. I want the origin to stay in the center. So if we look here in our extrude pop-up, we've got a whole bunch of different options to choose from. And the one that I'm going to change is going to be the direction. So if we open this up, well, you can see we've got 3 different options. The default is one side, then we've got 2 sides, and we've got symmetric. So I'm going to set this to be symmetric. Okay, when you do that, you see that you get a new option here, half length or whole length. I'm going to change this to be whole length. And now what I'm going to do is type in the total width of the part from the drawing, 110 millimeters. And you can see that with these settings, it takes half of that 110 and sends it off to the left and the other half to the right. And in doing so, it keeps the part symmetric about the origin, which is what I want here. So set in 110, symmetric, whole length, and then just hit OK. So now I've got my, my L-shaped part. And if I have a look at where my origin is, my origin should be sitting in the center of the part still. Okay, so that's the basic shape. I'm now going to go and start thinking about adding in some of the other features. So if I go back over to the sketch, you can see from a top-down view, there's this big cutout here in the center. Now, I'm overlooking all of these angled cutoffs here, all of these chamfers, because there's a tool for that I can use right at the end. What I am worried about, though, is this big 25 by 40 mil cutout, and that's what I'm going to do next. So in Fusion, in order to create that cutout, what I'm going to do is I'm going to create sketch, and I'm going to actually place the sketch on this sort of step surface here. So I'm placing a sketch on the surface of that step. Now that's rotated it in a different orientation of the sketch, which I don't really like, so I'm just going to use these arrows up here to turn that. Okay, that's a little better. Now, what I want is I want to make a rectangular cutout on this step. So I could do this with just lines and adding a lot of dimensions, or I can use one of the special items in the Create menu. Now that's in the rectangle section, and it's the center rectangle. So I'm going to take my center rectangle, and I'm just going to make a center rectangle. I'm going to try and place it on the y-axis or the vertical axis. Just going to do that. So there's a center rectangle. Your first click is the center, and your second click is one of the corners. Now, I might just go back a step and project that vertical axis. I think that's going to be useful. So P for project, and then find the vertical axis, which in this case is the x-axis. Okay, and I'm going to make sure that the center of my rectangle is coincident to that axis. Now it can't move side to side. Okay, and let's see, I might see if I can coincident the corner, bottom corner of the rectangle onto the bottom edge of the part so that my cut starts at the bottom edge. Okay, so that's now in place. Now all I should have to do is add some dimensions. So across here should be 40 mil. Okay, so you see that got wider equally in both directions because it's locked into the center of the part. And then if I change this to 25, it's staying locked down to the bottom here, and we're just changing the height. It's also turned totally black because we've locked it onto the edge of the part and into the center using the projected axis and the coincident tool. Okay, I can now finish my sketch and go in and try and remove some material here. So there's no special tool for removing that material. I'm simply going to use extrude again on a different setting. So grab your extrude, click on that rectangle, and this time I'm going to change a couple of different things. First thing I'm going to change is down here at the operation. I don't want to make stuff, I want to cut it away. So let's just change that to cut. And then I could type in the distance I want to cut, but really all I want to do is cut down to the bottom of the part. So under extent, I'm going to change that to say to object. Now what that lets me do is rotate the part around here, click on the bottom surface, and it will make that cut go all the way down to the surface that I've just clicked on. So you can control how far it's going without having to think about what the thickness of that part is. It also means that if I go back and I change that dimension there, the cut is still going to go the whole way through, which is useful if you ever go back and modify something. Okay, so we've got the cut out now. Let's take a look at what else I can do easily. So I've still got these chamfers here on all of these corners. I can see a dimension 3 by 45 mil, no, 45 degrees, sorry. So I might do those next because they're actually nice and easy to do. So you'll recall I said the modify menu had a bunch of different things that I could use. So I'm going to go to the modify menu and select chamfer. Now to use the chamfer, we just click on all the edges that we want to chamfer, and there's going to be 4 of them. Okay, and anything that you click on when you type in the dimension will be given a chamfer of that dimension. You should never really need to change any of the other settings. Most chamfers are equal distance. That's what it means when it says 45 degrees, equal distance. And I'm just going to put in the size of 3 millimeters, hit enter, and you can see now that those corners have been chamfered away. Nice. Okay, something else I can do very easily, I'm just putting off the holes till the end. Something else I can do easily is I can do these radii or fillets on the corners, radius of 6. So again, there's a tool for that, and that's just the fillet tool up here. Works very similar to the chamfer. You just click on the edges you want to give the fillet to. Shouldn't need to change any of the other settings, and then just type in the number of the radius, 6. And we can see that we have managed to give a nice radius there. Okay, so we're almost done. We've got one more thing to do, which is putting the holes in. So to put the holes in, I'm actually going to show you how to use the hole tool, which we've got up here, which is super useful. So to use the hole tool, we just need to have a sketch that tells us where the holes are going, where their centers are. So I'm just going to make a sketch that just has 2 dots in it, marking the centers. I'm going to grab my create sketch, and I'll just place it on this surface here. Okay, might just start by projecting a vertical axis. That might be useful in the long run. Guess we'll find out. Okay, I'm just going to go in here, and I just want to mark the centers of the holes. So I'm just going to grab this point here. I'm going to plop 2 points down, just like that. Okay, now I know this thing is symmetrical, and I know that they're level with each other. So to make sure they're level with each other, I'm just going to run a construction line between them, like this. And just double check that that's marked as horizontal, and it is, so that's good. Okay, now I know that those holes need to be 25 mil down from the top of the part, so let's pop a dimension on like that. And let's see what else have we got. They're going to be 30 mil from the edge. Put in the 30 there, and they're separated by a distance of 50, so I can dimension that line to be 50. Okay, so that should have locked those points in place. If you're worried they're not locked in place, just click on them and try and drag them around. If they're moving, they need another dimension. If they don't move, then you're fine. Okay, finish sketch. Now we're going to use the hole tool. So I'm going to click here for the hole tool, and I'm just going to select both of the dots. Okay. So those are going to be the center of my hole. Now, clearly, the last time I did this, I needed a huge hole. And so it's just default to that same size. If I look at my drawing though, I can see I've got some dimensions up here. So that's the diameter 6 through. So the through hole is 6 mil diameter. Then we've got a counter bore feature of diameter 12 and depth 5 mil. So the counter bore is diameter 12 and depth of 5, and it's in 2 places. There are 2 holes. And the hole tool will do all of that for us. So let's go have a look at some settings. Okay, so we can see that I've placed multiple holes from a sketch. I've got 2 of them, which is correct. And now we're going to have a look at the shape settings. So firstly, the extent. I don't want to have to type in a depth for the hole. I just want it to go the whole way through. So I could do 2 and go and click on the backside, or because there's nothing behind this, I can just say all. It will go through everything. And that's not a problem in this part because there's nothing behind it. Now the hole type, because it's a through hole, the hole type, I'm just going to set here to counter bore. So we've got 3 options, just a straight hole like you would drill with a drill bit, a counter bore, and a counter sink. We need the counter bore. Okay, we've got a hole tap type, simple, clearance, tapped, or there's a taper tap. So it will actually do a tap for you, which is lovely, but we just want a simple hole, basically, simple hole, so I'll leave it on there. And then the drill point can either be flat or pointy, but because we're going the whole way through, it does not matter at all, so you can just leave that on whatever it's set to. Then we're just going to tack in some dimensions. So the first dimension number up here is the diameter of the counter bore, so let's set that to be 12. We need the depth of the counter bore next, which is going to be 5. It wants the angle of the drill point. So if you take that away, it's going to make that option disappear. If you leave it in, you can set the drill point angle, but 118 is default. We'll just set it to flat to make it go away. And then we need a hole diameter, which is 6 millimeters. And then I can just hit OK. And if I zoom in now on this part, you can see that basically in one go, the hole tool has taken care of all of those features that I needed from that counter bore hole. So I'll just save that. And there we go. There's our part that we're trying to make. Something that's mildly entertaining but not super useful to do is to set either a material, which is more useful if you're trying to do like a weight estimate, or you can also set an appearance for it. And in the appearance menu, you've got all sorts of crazy options. Like you can make it a liquid, but this one I might set it to something like polished brass, so I can drag the polished brass appearance over there. Now it's changed color, so looks like brass. So physical materials also an option. You can get weight estimates using that, but this is just something fun. Okay, so there's our first 3-dimensional part. We might make one more in tonight's session, and I might pick one that requires us to use the Revolve tool just for a bit of variety. So I'm going to go back over to my selection of sketches. I had a few others up here. I've got this guy where you come in from the side and make this shape, and then you've got to stick a sketch on this angled face here, which is a nice one, but we'll skip over that. And we'll have a look at this part here, which requires a revolve. So the revolve tool is used when you're making something that's basically cylindrical or round, which this part is here, this valve lifter. So when you make a revolve for the right-hand side of it, and then we're going to revolve that shape around in order to make the full body. This one can pretty much be done in a single step. What I am going to do, just to make my life easier, is not put the radiuses, those 2 little R1s, into the sketch. And instead, I'm going to use the Fillet tool once I'm in the 3D shape. It just makes it a bit easier to do the sketch. Okay, so hopefully that was enough time to grab a screenshot of that. And I'll just pop back over here, open up a new part, and call this part 4. Okay, so I'm going to grab my sketch. I'm going to place that on the XY plane. And this time, I'm going to do the left-hand side, and I'm going to place the corner down at the origin here. So I'm going to be working over here in this second quadrant, basically. I'm going to start by projecting my horizontal and vertical axes. Like that, there we go. Okay, now I'm ready to start making this shape. So going to grab a straight line first of all. And I'm just going to go up the full height of the part. So starting at the origin, I'm just going to do a straight line that's going all the way up to the top of the part. And I'm just going to give that a dimension just for a sense of scale. I'm going to make that 25 mil. Okay, so there's the full height of the part. There's that little cutout down the bottom. I'm going to come back and do that a bit later on, I think. Okay, so when we get to the top of the part, we're going to have a bit of an arc shape. So I'm going to grab myself a center point arc. And now it's got to be centered on this line that I've just drawn. So make sure your first click is on that line, going up to the top. And then we're doing basically a quarter circle there. Okay. Straight line tool again, it's going to come down a tad. We're going to go over. Remember, I said I'm not doing those radiuses in the sketch just to make it easier. So over, down, over again, down, and then it just steps out a touch, all the way down and back over, and that's the turn plate. So there's the shape that I'm drawing here. And I'm going to come back and I'm going to put some dimensions in there in just a sec. Okay, so adding some dimensions now. That arc has a radius of 3 millimeters, so let's put that in. Okay, now let's see, this little step in is supposed to be 1 millimeter, so let's pop that in. Okay, now I'm pretty sure that this point here is supposed to be directly lined up with that one there, and they're not currently, so I could add another 1 mil dimension in, or what I'm going to do instead is put a construction line between those 2 points. That was supposed to be construction. Set it to construction, okay, and force that to be vertical. So now they're nice and lined up. From the drawing, I'm looking at the left-hand drawing. I'm going to add some sizes. So from the top down to there, that's supposed to be 7 millimeters. Okay, this here is 11. This step here is 4. And that leaves this last one to be 3. And if I try and do that, it's going to tell me it's over constrained because I've already given the full height. So I don't need to add that last one in. If you add everything else up, that will come out being 3. The last dimension that I need before I go and do that semicircular cut is just across the bottom. So I can see on my drawing, I've got diameter 7 here, so that's the full diameter. So I'm going to make this dimension here half of that. Okay, so I can just type in 7 over 2. Okay, so there's the outline of the shape there that I'm going to revolve. Before I revolve it, I'm just going to put in my little cutout down in the bottom corner, and I'm going to use the arc tool, the center point arc tool to do that. So first click at the origin, and then we're just doing an arc like that. And we just need to give that the appropriate radius. So it's diameter 3, radius will be 3 over 2. There we go. Now you could use the trim tool if you want. The trim tool will get rid of lines you don't want. So you can click on the trim tool and cut those out, but that's probably going to mess up my dimensioning. And it doesn't even matter leaving them in anyway, because when I select the area I'm going to revolve, I can just not select that little bit down there. So we get finish sketch. Okay, and now we're going to grab that revolve tool. So I'm going to grab that revolve tool. I'm going to choose the profile. So I'm going to pick this piece of the area and not that little bit down there, like I said I was going to do. I'm going to pick my axis, which is going to be that vertical axis. And you can see it's spun it the whole way around. Now it will default to 360 degrees, which is what I want. But if you didn't want that, if you wanted 180 instead, you could absolutely type in 180 and it will make you exactly half apart. Should that be something that you want, you can make it less or more. So I'll just reset that back to 360. Okay, so there's my full shape. I can just hit OK, and you can see now I have revolved the shape. I've got that little hemisphere cut out in the bottom that's turned out nicely. Okay, the only thing that I need to do is add in those radii that I left out because they're a lot easier to do in a 3D geometry. So I'm going to grab that Fillet Tool again one more time. And the Fillet Tool also works on circles and on curved lines. So I can just select that shape there, that circle there, and I can select that circle up there. And those both have a radius of 1. So we'll put in the number 1, hit enter, and we can see we've got the radii there. Okay, so that's using the Revolve tool to make something round in profile. I think that might be the last part we're going to make tonight, since we've been here for about an hour. I might just show you the other two drawings that I had lined up and talk a little bit about the tools, but I won't step through the whole process. So I had two other drawings here that we could have had a look at. Maybe we can in another session. So here is basically a piece of bent pipe, bent at 90 degrees with some flanges on either end. Now to construct that, you actually use quite an interesting feature of Fusion 360, which is up in this menu here. It's the sweep tool. As you can see from that little diagram that's popped up, what the sweep tool does is it lets you draw a line that will be the path that a shape gets drawn along. And then you also draw a cross section, which in this case is a circle, and it will take that circular cross section and drag it along the path that you've drawn. And so that's something that we could use to make a piece like this. We can make our circular cross section and then drag it along this quarter circle here, the quarter circle path. It's the sweep tool, pretty interesting. And then this one here, square transition bend. This uses two different things, well, three different things actually. First of all, you need a sweep. So you sweep your shape along this center line that's marked in red. It also uses something called a loft, which takes two different shapes and sort of merges them together. So a big square and a smaller square. And it also uses a feature called a shell, which takes a solid body and then just totally hollows it out so that it's empty the whole way through. So we've got all of that capability up here in either the create menu for that sweep or the loft, and the shell is up here in the modify menu. So a whole bunch of different options here. We also didn't look at doing offset planes or anything like that, but that's up there as well. Okay, I think I might wrap up at that point. Luann, are you still with us?
I am. That was excellent, Mel. We have a couple of questions for you.
Absolutely.
So the first question is, can multiple users work on a single diagram?
Ooh, that's a good question. I don't think that can be done simultaneously. So Fusion is cloud-based, so it's really easy to share parts with each other. You can give them basically like a link to your part and they can download a copy of it. But I don't think that you can be simultaneously working on the same part. You need to look into some other solution if you wanted to do that.
Okay, and the next question is, what can you advise about the other CAD programs easily accessible by FRC teams?
Okay, so like I said, Fusion 360 is good, I think, if you're just getting into it and you're limiting yourself basically to just doing like 3D printed stuff, because it's easy to download, it doesn't take a lot of storage, and you can get it on a Mac. If you've learnt to CAD on Fusion 360, the best one that you can use is going to be Autodesk Inventor. Obviously, they're both Autodesk products, so the transition is really easy over to that one. There's a lot of similarity in just like the layout and the options that you have and the way that it works. So if you've started with Fusion, I would suggest that you go over to Autodesk. It's also free and reasonably easy to download. So that's a nice, easy transition. On TDU, on 3132, we have moved over to using SolidWorks for a variety of different reasons. They're very, very similar programs though, so it just depends if you've got access to SolidWorks. I think that they're fairly similar. The last one is PTC Creo, which is a fairly unusual program and I think a little bit less popular and a little bit harder to use. So if you're looking for something that isn't Fusion, then either Autodesk or SolidWorks is a good choice. So Inventor or SolidWorks is a good choice.
Okay. Another question. Do you have any recommendations on how to move a team from single parts to a whole assembly? And if this person also wants to know if there are any resources you know of to do that.
Oh, going from individual parts to an entire assembly. I mean, it's a huge, huge jump. So I think you've got to take that in stages really. And it's going to take a lot of training. So we're doing individual parts here. You want to go in steps. You want to go from having just individual parts in the 3D printer to maybe doing a single assembly in CAD. Sorry, that's a doorbell going off in the background. You want to go from single parts over to like an assembly. So maybe that's like an intake mechanism or something like that, or maybe that's a gearbox. which also, like, it's a fairly complex thing, but it's also smaller. So try and build yourself up in steps. So, you know, you're still building your robot by hand and it's not in CAD, but you do have a component of the robot that you can put into CAD. And then as you sort of grapple with that sort of problem and get a bit more confidence, then you can start putting more and more of the robot in there. If you're using a kit of parts drive base, that should be, I want to say, reasonably straightforward to get into CAD. You can download most of the parts for it from the Andy Mark website, and then it's just a matter of assembling it. So you have that base in CAD that you can add the assemblies on, and then work yourself up from there. In terms of resources, I don't know of any off the top of my head. I'm sure there are some out there. I would probably direct you guys towards the Compass Alliance website, because there's heaps of great resources on there, all shapes and sizes. So have a look perhaps on the Compass Alliance, I would say.
We have one more question. How would a low resource team without a lot of machining use CAD to make parts?
Without a lot of machining, so I mean, if you don't have a 3D printer, what can you be using CAD for? Well, you know, if you've got different people that are the designers versus the manufacturers, even if you've got no machine tools or anything like that, it's still, I think, a good tool to have, because the designer can be making, you know, instead of just handing off this rough sketch to the manufacturing team, they can go into CAD, CAD up an individual part or a couple of parts, double check in CAD that those parts actually fit together before they go over to the manufacturing team. And then in Fusion, you can actually take a part and produce a proper engineering drawing for it. It's got that capability. So, you know, you model your parts, you check they fit together, you produce a nice dimensioned engineering drawing, and then you can hand that over to your manufacturing team. And even if all they're doing is taking a piece of sheet metal and cutting it by hand and drilling the holes by hand and marking it by hand, you know, they've still got a good engineering drawing to go off, and you can have the confidence that your 3 or 4 components are going to fit together after they've been made.
Great. Well, those are all the questions that we have for now. There was one comment in here that Onshape is a browser-based CAD program that allows multiple users to work on a scene at the same time. So I guess there is an answer in chat to one of the questions. So I want to say thank you, Mel. That was great. There have been a lot of people thanking you in the comments. I also want to say thank you to Project Bucephalus for helping to manage the whole process tonight. That was awesome. And I just wish everybody a really good night. Bye.
All right, thanks for having me, Luann.